Hi everyone. So in the previous lecture we studied about voltage feedback topology. Now we are going to study about voltage current feedback topology. So voltage will be sampled and it will be converted into current and it will be mixed with the input current. So we have already seen the diagram. So voltage is sampled, converted into current and it is mixed with the input current. So in the input I in minus I of current is going. Now what we are going to find? Closed loop gain, closed loop input impedance, closed loop output impedance. So what is the open loop gain? Open loop gain is Rm. Open loop gain is Rm because current is being converted into voltage. So voltage by current is Rm. So and that will have the unit of ohm. Sometimes it will be written as A as well. It can be written as A as well. That what they can say is that your open loop gain is A, but the gain A will have the unit of ohm. But I am showing it here as Rm. So the gain A will have the unit of ohm, right? So it can be shown as A as well. Now similarly, this feedback factor can also be shown as beta as well. But this feedback factor beta will have a unit of Mahu, right? So any notation can be given. Here we are giving Rm and Gm notation for simplicity, right? So what was happening? So your output is being sampled, your V naught is being sampled, it is coming as it is, and now it is giving us Gm V naught current here. And what is the current going into the input? That is I in minus Gm V naught. Now this is amplifying the current. This Rm is amplifying the current and converting it into the voltage. So what is the current coming into the amplifier? The current coming into the amplifier is I in minus Gm V naught. Now this current will be amplified by the factor of Rm and will give you voltage V naught. Say yes or no, right? What is your target to find? What is your gain? Gain is gain. I will write gain, or you can write A trans resistance. What is this amplifier? This amplifier is trans resistance amplifier. So I am writing the gain as AR after feedback. That would be output voltage upon input current. This is your closed loop gain. This is your closed loop gain. What kind of amplifier is that? What kind of amplifier is that? This is a trans resistance amplifier because output is voltage, input is current. So this is trans resistance amplifier. So I am writing gain A, R resistance, F means after feedback. So after feedback, what is the gain you are getting? After feedback, what is that trans resistance gain you are getting? So this is how I am writing it. Let's move it downward. Okay, so your target is to find V naught by I in. So what will be your V naught by I in? So V naught by I in from here you can get to know is that is your trans resistance amplifier with the feedback. The gain is Rm upon 1 plus Gm Rm, and we know why this gain is there because in negative feedback the gain is A upon 1 plus A beta. What is A here? A is Rm upon 1 plus A beta. A is Rm. What is beta? Beta is Gm. So this is the gain we are getting. Well and good, very easy. Gain expression is very easy. Let's move to the input impedance. So now you need to find the input impedance. So let's take this Rm a bit this side because I will have to make the input impedance. Now what this input impedance will do? What this input impedance will do? Whatever the input current is coming in the impedance, it will amplify that current. It will amplify that particular current. Now you need to find R in after feedback. This is what you need to find. So what that will be? Let's just assume if it is having V in voltage. So what will be your R in after feedback? That would be V in by I in. Say yes or no. R in after feedback would be V in by I in, right? Now if this voltage is V in, that means this node is minus sign, this node is minus, and if this node is plus, that means this node is plus. Did you understand this point? Voltage is sample here, no? Sorry, voltage is not mixed. Voltage is coming as it is because this is shunt. This is shunt connection. So voltage will come as it is. This I am saying that current source is having V in voltage. That means this node is negative. So negative is trailing here, and this node is positive. So positive is trailing here. Same in the manner, this node is negative, so negative will be traveling here, and this node is positive, so positive will be traveling here. So here also you will be having V in voltage, but that doesn't matter. This is of no use. We just need to know the voltage here. So the voltage here is V in. I hope you understood it. Now the same voltage V in is going towards R in. The same voltage V in is going towards R in. So what will be the current in R in? What will be the current in R in? That will be V in by R in. Right? What is the use of amplifier? Whatever the current is there into the input resistance, whatever the current is there, that will be amplified and will give you in the form of voltage. So what current is there in the resistance? That is V in by R in. So that will be amplified. V in by R in will be amplified with the factor of Rm, and it will convert into voltage. V in by R in was the current. It was amplified with the factor of Rn and it was converted into voltage. So what is this voltage? What is this voltage? This voltage is V in by R in into Rm. Now this is being multiplied with the factor of Gm. So V in by R in into Rm into Gm. Oh, sorry. That will be a current, right? Voltage multiplied with Gm will give you the current. And what will be the current direction I will be taking? This is the current direction that I will be taking. Let's just call this voltage as V0 only. If this voltage is V0 only, so what will be this current? This current will be Gm V0 only. So what is the input current that is actually going in there? That is I in minus Gm V0. I in minus Gm V0. But that is actually is of no use. Why is it of no use? Because our target is to find V in by I in. This is our target, right? Yeah. So what you can write? Now this current V in by R in. V in by R in. This current is equals to I in minus Gm V0. Say yes or no. Now you know the expression of V0. You can put this expression as well, but let's just determine it independently. So you know the expression of V0 as well. What is the expression of V0? V0 is V in by R in into Rm. So V in by R in is equals to I in minus Gm. What is V0? V0 is V in by R in into Rm. Say yes or no. Are you able to understand this point? So V in into 1 plus Gm Rm divided by R in is equals to R in into I in. So V in by I in. So R in with feedback would be R in upon 1 plus Gm Rm. This is the feedback resistance. How did we derive it? Look, our target was to find V in by I in. Then I know that whatever the current that is there in the input resistance, that will be amplified with the factor of Rm. Whatever the current that input resistance gets, what was the seen in voltage amplifier? Whatever the voltage input resistance is getting, that was amplified. इनपुट रेजिस्टेंस के अक्रॉस जितना भी वोल्टेज आएगा वो एम्पलीफाई हो जाएगा. इसमें इनपुट रेजिस्टेंस में जितना करंट आएगा वो एम्पलीफाई हो जाएगा. सो वट एवर द करंट इनपुट रेजिस्टेंस इज टेकिंग दैट इज बीइंग एम्पलीफाइड. सो द करंट दैट इज टेकिंग इज V in by R in. The current is V in by R in, that is being amplified. V in by R in into Rm is equals to V0. Now that is being fed back towards the input side because in the form of current. The current is Gm V0. Right? So we could write down the expression that your V in by R in is equals to I in minus Gm V0. That current is I in minus Gm V0. And you know the V0 value in terms of V in R in and Rm. So I replaced it and I got to know this final expression. Now, how will you remember this expression? What kind of amplifier is that? Trans resistance amplifier. So what is the input? Input is the current. If current is the input, so you want your R in value to be high or low? If the current is input, you want your R in value to be low so that more current goes. I hope you remember it. This was the currents of Is, this was your Rs, and this was the input impedance of amplifier. So you want more and more current to go here. That means you want this to be low. If this is low, then more and more current will go. So R in upon 1 plus GMRM. Say yes or no. Agreeing to this point? Well and good. So this is your R in with feedback. Tell me what will be your R naught with feedback? Output impedance. Closed loop output impedance we need to calculate. So we are calculating closed loop output impedance. So we have already open circuited the current source. We have already open circuited the current source. This was the current source we were having, that has been open circuited already. Say yes or no. Let me make a clearer diagram. Okay, yeah. So now I need to calculate output impedance. So what will be my output impedance? From here I will be calculating my output impedance. So output impedance after feedback, that would be V naught by I naught, right? Now this V naught completely will be going here, and the same V naught will be copied here as well, because this node is positive and this node is negative, and the current here would be GM V naught, right? This current would be GM V naught. If this current is GM V naught, that means this current is also GM V naught, because there is no current coming from here because input is gone. So this current is also GM V naught, right? But you needed the input current. So what it will give you? It is converting into it is converting current into voltage source. Current into voltage source. Current into voltage source. And then there is a R naught resistance as well. Now what will be the value of that current source, that voltage source? Tell me. Is it GM V naught RM? Is that correct? No, that is wrong. Here there will be negative sign as well. Why there is negative sign? Because if GM V naught was current was going in, then it was giving you the factor of RM. Now the current is going out, so you have to take a negative sign, because the input current is minus GM V naught this time. The forward path should have input current. The forward path should have input current, but that current is outward. So you should write minus GM V naught into RM. This potential is minus GM V naught into RM. So now you can, again there will be an assumption. What will be the assumption? That complete I naught is flowing through R naught. This is your R naught. What is the assumption? Complete I naught is flowing through R naught. This is the assumption we are taking, right? So what will be V naught by I naught? So this potential is V naught, and this complete I naught current is flowing here. So V naught minus of minus GM V naught RM. So V naught plus GM V naught RM divided by R naught is equals to I naught. So what will be your V naught by I naught? V naught by I naught, that is R naught with feedback. That would be R naught upon 1 plus GM RM. That's it. R naught upon 1 plus GM RM. And how will you remember it? What it is doing? What is the output? Output is the voltage. Output is the voltage. So you would want your R naught to be as low as possible, so that more and more voltage is coming across the load resistance. You want your R naught to be low. That's why R naught upon 1 plus GMRM. So R naught is decreasing. Here also Rin is also decreasing, because in trans resistance amplifier input is the current. So you want your input resistance to be as low as possible, so that more and more current is coming. Well and good. So this was the gain Rm upon 1 plus GMRN. This was the input resistance. This was the output resistance. Derivation is not important, but you should have a clear idea how the derivation is made. Because what if they make some other block and then they can ask you the derivation? They can design anything. IIT's professor can design anything. They can design any block and they can make you use of this derivation. So you should be comfortable with the derivations as well, right? All good. So in this derivation we saw that this current was I in minus GM V naught. So intelligently we could derive the expression. Here also intelligently we could derive the expression. Let's move on to our question now. So first thing, what kind of topology is that? And before that we will determine what kind of feedback is that. So let's try. What we will do, we will increase the output. If this output is increased, what will happen to this node? This node will go down, right? If this node is increased, this node will go down. This current is gone, because when we are seeing the type of feedback, we don't consider the input source. We don't consider the input source. So let's just forget it. We don't consider an input source. If this is increasing, this is going down. If this is going down, that means this is also going down. And if this node is going down, So basically this node is also going down. That means there is negative feedback. So there is negative feedback. So this can be the first question to determine the type of feedback. So the important thing is, for determining the type of feedback, you will always nullify the input. So current source is gone, V node is increased, this node is decreased. If this node is decreased, the upper node is also decreased, because from here to here there is 0 degree phase shift. From here to here there is 180 degree phase shift, right? This node is also going down. So this is a negative feedback. Well and good. Now what kind of topology is there? What kind of topology is there? Let's try doing it with the method. So let's see the mixing. If we are seeing the mixing, what do you need to do? We will see the current mixing. If the current is getting two paths, this is the input current. Now is the current getting two paths? Yes. One path is there, one path is here. So current is getting two paths now. So there is current mixing. There is current mixing. So you can show it like this as well. Yeah. So there is current mixing. What is the next thing? Sampling. How do you see the sampling? So for sampling, what do you do? You see the voltage, you see the output voltage. So if I put output voltage equals to 0, what will happen? There will be no current here. This feedback current will be 0. This feedback current will be 0. If I put output equals to 0, this feedback current will be 0. That means there is no feedback factor. There is no feedback involved. If I put V0 equals to 0, there is no feedback involved. If there is no feedback involved, what does that mean? That means if V0 is 0, your feedback component is 0. If your feedback component is 0, that means there is voltage sampling. Understood? Why there is voltage sampling? If I put V0 equals to 0, there is no component of feedback. If feedback component is being 0, because feedback component is depending on V0. If feedback component is depending on V0, that means there is voltage sampling. So there is voltage sampling, right? Current mixing and voltage sampling. So what you can say, voltage current feedback topology. Voltage current feedback topology. Well and good. Now let's solve the question. The question was, you need to determine V node by I in and Rx and Ry. Two method. Method 1. What is the method 1? Without using the concept of feedback. Without using the concept of feedback. Without using the concept of feedback. Let's solve this particular problem. And let's keep it here. Okay. So if this node is V node, so how much current is there? That is GM to V node. And this current is I in. What will happen to this VB? This VB will be shorted. And what will happen to that VDD? That will also be shorted. Right? This is what you need to find, V node by I in. No? V node by I in. That is our target, to find V node by I in. So what is the current here? What is the current here that you don't know, right? Or you know. If I put V voltage there, yeah. So what I can do is that, what I know is that this current is 0, right? This current is 0. This current is flowing like this. This current is 0. This current is 0 ampere. So if I put V naught here, if this is your V naught, so this current is V naught by RD, right? Now this V naught by RD current is not going here. This current is 0 ampere. So what is this current? This current is certainly V naught by RD. Did you understand this point? I intelligently solved it. Look, this current was completely 0. So if V naught is going here, that means the upper current is V naught by RD. So no current is going in this path. So certainly in this MOS, V naught by RD current is going. In this MOS, V naught by RD current is going. So my target was to find I in by V naught by I in, right? V naught by I in. So let's find it out. What you can say? I in is equals to GM2 V naught plus V naught by RD. So what will be your V naught by I in? That would be RD upon GM2 RD plus 1. That's it. This is the first answer without using the concept of feedback. Second, you need to find Rx. What you need to find? You need to find Rx. So let's make a different circuit for that. Or in this only we can do it. Let's make a different circuit. Look, I am not mugging up any method here, right? Because I'm just solving all those questions in front of you only. I'm not remembering what will be the answer. So by this method also you should be also able to get to the final answer, right? So slowly you will be developing the habit. But since we have solved so much of questions, I hope you have developed the habit till now. This is your V naught, so this would be GM2 V naught. My target is to find, what is my target? My target is Rx, that is my V in by I in. So this potential is V in this time. This potential is V in. So my target is to find V in by I in. Right? So this potential is V in. Now if this potential is V in, what is the current here? What will be the current in the upward direction? That would be GM1 V in. Yes or no? If this potential is V in, so V in minus 0, current would be GM1 V in. So what will be this potential? Current will be in this direction and VDT is already gone. This potential will be GM1 RD into V in. This potential will be GM1 RD into V in, and the same potential will be coming here, GM1 RD. Why did I say the complete current is flowing through RD? Because there is 0 ampere current here, right? So this node would be GM1 RD into V in. If this node is GM1 RD into V in, so what will be this current? This current would be, what will be this current? This current would be GM1 GM2 RD into V in, right? So from I in, what do you see? I in is equals to, in the upward direction there is current GM1 V in, GM1 V in, and in this direction also there is current, that is GM1 GM2 RD into V in. So what will be your V in by I in? V in by I in, 1 by GM1 divided by 1 plus GM2 RD. GM2 RD, 1 by GM1, 1 plus GM2 RD. So this is your Rx voltage, right? This is your Rx voltage. So second answer we have got. What about the third one? You need to find Ry. For Ry, this I in will be gone. So let's make another circuit. Now you need to find Ry. So I in will be gone, right? This VB is already shorted. This will also be shorted. You need to find Vy by Iy. What you need to find? Vy by Iy. Vy by Iy. This is what you need to find, right? So if this is Vy, this will also be Vy. Well and good. And if this is Vy, this will also be Vy. Right? If this is Vy, this will also be Vy. So here the current would be GM2 Vy, right? And this current would be Vy by RD, right? Yeah, so what I was saying, so here GM2 Vy current is there and here Vy by RD current is there. So what is the current here? The current here is 0 ampere, right? This current is 0 ampere. Now you cannot say this current will also be 0 ampere. No. This current will not be 0 ampere because this is Vy by Iy, so this will drive Iy current. Say yes or no? Look, in the previous case, why did we say that the complete loop will have 0 ampere current? Why is it so? Because there was no source here. But if you are calculating Vy, if you are calculating Vy at the output node, if you are calculating Vy, so you are connecting a battery there. You are connecting a battery of Vy and getting Iy current out of it. So I have connected a Vy battery and I am getting Iy current out of it. So that means now it can drive some Iy current. So here there is 0 ampere current since this is gate, but this Iy current will be going in this path. So now what is the scene? Now this is GM to Vy, this part is open circuited. So this GM to Vy will be flowing through this MOS as well. This MOS. You can say this GM to Vy will be flowing downward. GM to Vy. So what you can say? Iy is equals to, at this node if you say Iy is equals to Vy by Rd plus GM to Vy. Say yes or no. So what will be your Ry? Ry will simply be Rd parallel with 1 by GM2. Since we have done enough MOS circuit analysis, this is very simple for us. Although this was good intuition here, what was the intuition? That this will be having 0 ampere current, so Iy current will be flowing here. This Vy would be coming here, so this MOS is driving GM to Vy current. The gate is not driving this current. Gate is not driving, this MOS is driving this current. Now this current will be flowing through M1 as well. The same current will be flowing through M1 as well. Now the same current is flowing through M1 as well. Vy Rd current is going that way. GM to Vy current is going that way. So Iy is current is equals to Vy by Rd plus GM to Vy. So Ry is equals to Rd parallel 1 by GM2. Say yes or no. Is that correct? Correct. Is there any issue with that? No issue with that. So what is our final answer? We can write down the final answer of this. Rd parallel with 1 by GM2 are not. So Rd upon, it would be Rd upon 1 plus GM2 Rd. So if you solve it, this is what you are going to get. This is your Ry. After solving, this is what you are going to get. Rd upon 1 plus GM2 Rd. So are you getting something? 1 plus GM2 Rd, 1 plus GM2 Rd. I hope you are understanding something here. Okay, so now we are going to solve with the concept of feedback topology. So before my solution, you need to solve it on your own with the concept of feedback topology. So now we are going to solve with the concept of feedback topology. But in the examination, I am pretty sure we are going to solve by this method. Everyone is going to solve by this method. Even I will also be solving by this method. Okay, but here we are learning the concept. So we are going to solve with the concept of feedback topology. I know this concept is a bit typical. I know this is a bit typical, but this is not taught in this much of great manner. I am pretty sure no one is going to teach you in this kind of manner. So examination question will be very easy for you. Even the interviewer question will also be very easy for you. Just you need to follow the notes, whatever that I am teaching. That would be much more than enough. And then there are test series available as well. Everything is available, so no need to worry about anything, right? Now we are going to solve with the concept of feedback topology. So first thing is we need to make the open loop. So for making the open loop, we have to break the feedback path. So which one is the feedback path? This is the feedback path. So we have to break this path. Now how it will be broken? Tell me. So what is the scene? What we are studying? Voltage current feedback topology. Voltage current feedback topology. So our input is current. Input is current. Input is current. Current was converted into some voltage. Some voltage was fed back in the form of current GM V naught, and this was I in minus GM V naught. Well and good, this was happening. I in minus GM V naught, and this was the input current that was going, and then you were having the output. Well and good. Okay. So now if you need open loop here, so what does that mean? You need zero current. Zero current should be coming in. this current should be 0. So if you are breaking the loop here, what you should do here? It should be open circuit or short circuit? Tell me. It should be open circuit, because in the feedback path there should be 0 current. In the feedback path there should be 0 current. If you need 0 current, that means you need to make it open circuit. So you need to make it open circuit. So let's make the feedback system now. This is RD. Certainly this VDD will be gone. This was your bias, that will also be shorted. And this was your current source. And this needs to be open circuited. If you are breaking the loop, when I am breaking the loop, one thing I am making sure is that, what is that? In the feedback path there should be no current, because this is the current that we are getting from the output. We are getting the current. So in feedback path there should be no current. If I want 0 current, what does 0 current mean? 0 voltage means short circuit. So in the previous time we did short circuit, and 0 current means open circuit. So here we are doing the open circuit, because I need 0 current. If I need 0 current, I have to open circuit it, right? And if I short circuit this, what would have happened? This complete IN will be flowing here. So IF would have been IN, and this is not what I want. For open loop, I want 0 current. So this is the open loop we are doing. Right, and this is your V naught. This is your V naught. Now V naught is being fed to the gate of M2, and this gate is grounded. This is M2. What will happen to this? Look, there is some feedback current, that is GM V naught. Now that current has to sustain. That current, GM V naught current, has to sustain. If I keep it open-ended, what will happen? If I keep it open-ended, that current will not sustain. GM V naught current cannot flow. So I have to short circuit it. So this side will be shorted. Now let's back to the previous concept. What did we do in the previous one? We broke the loop. We needed 0 voltage in the feedback. So we shorted it. And here we open circuited it. Because here there was beta V naught voltage. Although beta was 1 only. So here there was beta V naught voltage that has to sustain. The beta V naught voltage has to sustain. If I had shorted it, V naught would have gone to 0. The feedback voltage would have gone to 0. But that voltage has to sustain. So that's why we made it open circuit. So at one node was shorted, one node was open circuited. Are you getting this point? And here, this node is open circuited, this node is shorted. So this is how we broke the loop. This was the loop which was broken. So this node is shorted and this node is open circuited. So did you understand why we are doing so? When in the examination it is very tough to click. So what we will do, we will draw the block diagram. Then we got to know that we need 0 current in the towards the input side. We need 0 current. That's why this side will be open circuited. Now there is a feedback current that has to sustain. The feedback current has to sustain. That's why we will short circuit this. The feedback path that will be shorted. That's why we will short circuit this. So this is what we are doing. Well and good. So this is our open loop now. Now in open loop we can find everything. So what is the first thing I am going to find? I am going to find open loop gain. So what will be my V naught by I in open loop? Tell me, V naught by I in open loop. So this I in will completely be flowing here. Say yes or no. So V naught by I in open loop is RD. That's it. So this is my RM actually. RM. RM value is RD. Can we relate? RM value is RD. Right? And what will be my R in open loop? R in open loop. I will apply V in here and get I in out of it. So what will be my R in? R in, or you can say RX open loop. Better I should say RX open loop. So what will be my RX open loop? From here, if I see, it would be 1 by GM1. If this is M1, it would be 1 by GM1. 1 by GM1. My RX open loop is 1 by GM1. What about R not open loop or RY open loop, you can say RY open loop. So this is the best analysis. What will happen? This current source will be gone. If this current source is gone, this will not drive any current. So only current that will be driven by will be by RD. So RY open loop will be RD. Now people will say, sir, this will drive also current GM to V0. No issue, because from here there is 0 ampere current, right? So from V0 node, what do you see? From V0 node, there is 0 ampere current and there is V0 by RD current. So if you get I0 current out of it, so what will be your V0 by I0? V0 by I0 would be simply RD only, because V0 by RD is equals to I0, because there is 0 ampere current. Although it is driving GM to V0 current, but that is going into the ground. There is no use of that current. I just need V0 by I0. So V0 by I0 would be RD. Are you getting this point? This is V0. V0 by RD is equals to I0, because this In is gone. If this In is gone, there is no use of this MOS. If there is no use of this MOS, so simply V0 by RD is equals to I0. So V0 by I0 is equals to R0. Well and good. V0 by I0 is equals to RD actually. Very simple thing, right? Let's remove this up. Let's remove this up. Let's remove this one as well. This was In. So RY open loop is RD only. Now tell me, what is the feedback factor? What is the feedback factor? So for feedback factor, this was your IF, right? This was your IF. What is the current flowing here? GM to V0. What is your IF? IF is GM to V0. Wait a second. IF is GM to V0. What is your feedback factor? IF by V0, that is equals to capital GM, that is equals to GM2. Your feedback factor is GM2. Voltage was converted into current. Voltage was coming, it was converted into current. So voltage was converted into current, right? So IF by V0 is our GM. Here also you can see in the block diagram, the voltage was converted into current. Voltage was converted into current. So this is our IF. This was our IF only. So we were calling it IF only, right? This was our IF. So what is our feedback factor now? Feedback factor is GM2. Now I can calculate everything. First thing is closed loop gain. What that would be? Rm upon 1 plus GM Rm. What is Rm? Rm I got was Rd. Open loop gain divided by 1 plus feedback factor. Feedback factor is GM2 divided by into open loop gain. Rd upon 1 plus GM2 Rd. This is what I got. Rd upon 1 plus GM2 Rd. So this I am solving with the concept of feedback topology as well. Well and good. This is our closed loop gain. Let's find other things. Closed loop input impedance. So what that would be? Rin with feedback. So that would be closed loop input impedance. What kind of amplifier is that? Output is voltage, input is current. Output is voltage, input is current. So this is a trans-resistor amplifier. Current input is current. So Rin should be as low as possible. So Rin without feedback. What was Rin without feedback? Rin open loop. That was 1 by GM1. 1 by GM1 divided by 1 plus GM2 RD. Right? This is your Rin with feedback. What about your R0 with feedback? So this should also be decreasing. This should also be decreasing. So R0 without feedback was RD. So RD upon 1 plus GM2 RD. That's it. So did I calculate the same values previously? RD upon 1 plus GM2 RD and 1 by GM1 upon 1 by GM2 plus R upon 1 plus GM2 RD. Everything is similar. So I hope you are understanding the concept here. What did we understood? First we started with simple configuration. This is our simple configuration. Voltage, current, feedback. Voltage is being fed. It is being converted into current. Now open loop gain we have, input impedance we have, and output impedance we have. All are open loop. Then we found out the expression of closed loop. Gain would be reduced Rm upon 1 plus GM Rm. Similarly, input impedance will also be reducing because this is a trans resistance amplifier. For trans resistance amplifier, input is the current, so it would want Rin to be as low as possible so that maximum current can go in. And what about output impedance? Output impedance will also be decreasing because output is the voltage. It would want more and more voltage across the load. If it is having more and more voltage across the load, that means R0 should be as low as possible. So both are decreasing by the factor of 1 plus A beta, where A is Rm and beta is Gm. Right? Then we solved the question. First we solved without the concept of feedback topology. This was also good question even if we are solving without the concept of feedback topology, because there you smartly need to see how much current is there. So there was 0 ampere current here, so V naught by RD, then you need to apply good equations. Then you got to know V naught by I in is RD upon GM2 RD plus 1. And then we saw the input resistance. So for input resistance we need to calculate V in by I in. So from there we also calculated that I in is going completely there because 0 ampere current is flowing in the loop. In the loop there is 0 ampere current. So I could make it somewhat like this. There is 0 ampere current here in the loop. So complete I in was going there. So yeah, this was GM1 V in into RD. So that was going there. So here we could write down the current GM1 GM2 RD into V in. So V in by I in would be 1 by GM1 divided by 1 by GM1 divided by 1 plus GM2 RD. And then we saw the output impedance, that was RD parallel with 1 by GM2. It was also very interesting. Why it was very interesting? Because there was two component of IY current. One was driven by the M1 MOS. M1 MOS was taking, but it was driven by the M2 MOS. M2 MOS was giving GM2 VY current, and M1 MOS was taking that current, that was GM2 VY. And in RD resistance as well, there was a current that was VY by RD. So two components was there. So RY was RD parallel with 1 by GM2. RD parallel with 1 by GM2. Although here there was 0 ampere current, but this current was not 0. So this current would have been IY, and the same current was flowing through M1 as well. So GM2 VY and VY by RD. So RD parallel with 1 by GM2. So RD upon 1 plus GM2 RD. Then we made the open loop. For open loop, what did we show? The current is going in, so I don't want any current. So this node will be open circuited and other node will be shorted because the current needs to be sustained. So current needs to be sustained. So this would not be, so we made the open loop now. Now we can write down the open loop open loop gain as well. What will be the open loop gain? Open loop gain will simply be, what we need to find, V naught by I in, so it would be simply be RD only. What is the open loop input impedance? What is the open loop input impedance? 1 by GM1. What is the output impedance? Only RD, because M2 is driving some current, but that is going into the ground only, that is of no use, right? Only from V naught, only V naught by RD current is flowing, so that is RD, right? Then we needed to determine the feedback factor. What was the feedback factor? Feedback factor was GM2. So from there we determine the feedback factor. Then closed loop gain we could write, open closed loop input impedance we could write, and output impedance also we could write. So this is how we solved the problem. Well and good. Understood everything. Let's move on to our next feedback topology, that is current voltage feedback topology. So output current is going in, output current is fed back, and then output current is sampled and it is fed back towards the input in terms of voltage. So input is voltage and output is current this time. Input is voltage and output is current. So this will have mho and this will have ohm as a unit, right? Current is sampled and it is fed back in terms of voltage to the forward gain. So what is your open loop gain? That is GM. Open loop gain is GM. What is your open loop input impedance? That is Rin. What is your open loop output impedance? That is R0. So after feedback, what will be your closed loop gain? Since this is a negative feedback, simply you can write GM upon 1 plus GM Rm. We are not deriving the expression this time because derivation is not that important. Two derivation we have already seen. You can derive all the expression on your own now. You should be doing it on your own. What should be your closed loop input impedance? Closed loop input impedance. Try thinking about it and then tell the answer. What kind of amplifier is that? This is a output is current, input is voltage. Output is current, input is voltage. This is a trans conductance amplifier. What is input? Input is voltage. So what do you need? You want more and more voltage across the input resistance. You want more and more voltage. If you want more and more voltage, that means Rin should be higher. Rin should be higher. So Rin should be higher. So Rin into 1 plus A beta. What is A beta? GMRM. Right? And what about closed loop output impedance? What is your output? Output is current. What is your output? Output is current. So if output is current, you would want less current in the output impedance but more current in the load. So you want more and more current in the load, so you would want your R0 to be as high as possible so that more and more current can go into the load. So you want your R0 to be as high as possible. So R0 with feedback would be R0 into 1 plus A beta GMRM. That's it. Everything you have found out. This is your closed loop gain. This was your closed loop input impedance. Right? So in this manner you can write down without even deriving the expression. Well and good. Now let's see the question directly. First thing, determine what kind of feedback is that. I am giving you 30 seconds for this. Tell me what kind of feedback is that. Let's start. Okay. If this I naught increases, if this is the I naught that is flowing through this small r, if this I naught increases, what will happen? This node will increase. Right? If this node increases, then what will happen? Vin will be shorted. You don't need to see at Vin. You don't need to see at Vin because Vin will be shorted because we are determining the feedback. If this node increases, then what will happen to this node? This node will go down. And if this node goes down, what is this? This is a common source amplifier. You are going from gate to drain. If this node is going down, that means this node is going up. So what kind of feedback is there? This time the feedback is positive feedback. Right? If I out increases, this node will increase. If this node increases, then this node would decrease. If this node decreases, that means this node will increase. If this node is increasing, then certainly this node will increase only. If this node decreases, then this node will increase. And if this node is increasing, that means this node will certainly increase. So you tried increasing it and the node is increasing. So that means this is positive feedback. This is positive feedback. So here the feedback is positive. So this question will be interesting now. Right? You need to find I out by V in Rx and Ry. You can find it without the concept of feedback very easily. So let's find it without the concept of feedback. That will be very easy, but with the concept of feedback, you need to use your brain this time because now there is positive feedback. So with the concept of feedback, you will have to use the brain. So first let's just I'm not sure if I told you that your input source should be nullified when you determine the sign of feedback. When I was teaching the sign of feedback initially, I forgot to tell that your input source should be nullified when you are checking the sign of feedback. And there is one more point. It's not that you need to start from output only. You can start from any node. Let's just assume I am starting from this node. So you can start from this node, walk around the loop and come back to this node. If you increase this and if this is decreasing, that means the complete circuit is in negative feedback. So it is not certain that you need to start from output only. You can start from any node, but generally we start from output. Are you getting this point? So in the complete circuit, you can start from any node. You start increasing that and then see what happens. But that node should not be fixed. It's not that, sir, this is grounded, so I am starting from here. If I increase this, this is grounded, the voltage is fixed here, so you can't increase it. Okay. And so two things are there to determine the sign of feedback. What are the two things? First thing is that you will short circuit the input source. If it is voltage source, you will short circuit it. If it is a current source, you will open circuit it. You just nullify through you just need to nullify the independent voltage source, the voltage source and current source. Then what you will do, you will increase any node voltage, walk around the loop and see if the voltage is, if that node voltage is getting increased or decreased. If that node voltage is getting increased, that means there is positive feedback. If that node voltage is getting decreased, that means there is negative feedback. Well and good. Very easy concept, very straightforward. Let's try solving this problem without the concept of feedback. So method 1, without the concept of feedback. What do I need to find? I out by V in. Okay, I out by V in I need to find. This is my I out current. What this node voltage would be? This would be I out into R. This node voltage would be I out into R. So what will be the current here? The current would be GM1 I out into R minus V in. Now this current will be flowing here. This VDD and all those things will be gone. Now this current will be flowing here. If this current is flowing here, what will be this node voltage? This node voltage will be, this is plus minus, so this node voltage will be minus GM1 RD I naught R minus V in. Now what will be the current downward? The current downward would be, that would be GM2, because 0 minus this GM2 GM1 RD I naught R minus V in, and thus this current will be equals to I naught only, right? This current will be equals to I naught only. Well and good, very simple expression. This is just network analysis, कोई दिक्कत वाली बात ही नहीं है इसमें. I naught R, the current is downward, that is GM1 I naught R V in. If the current is downward, that means the voltage drop is like that. So minus GM1 RD I naught R minus V in, right? And the current downward would be GM1 GM2 RD I naught R minus V in, and that current is equals to I naught only, and this current is equals to I naught. That's it. Now you just need to tell the value. So what will happen? GM2 GM1 RD R I naught minus I naught would be equals to GM1 GM2 RD V in. So what I need to find? I out by V in. What will be my I out by V in now? That would be GM1 GM2 RD upon, let's just call this as minus sign, and then I can write 1 minus GM1 GM2 RD R. That's it. This is your I out by V in. Say yes or no. Minus GM1 GM2 RD upon 1 minus GM1 GM2 RD into R. Well and good. This is your I out by V in without the concept of feedback you are getting. Now you need to find Rx and Ry values. So let's find Rx and Ry values. For Rx value, I need to get I in current here. Now this I in current will be flowing completely here because there will be 0 ampere current here. Now this I in current is flowing here in this direction. I in current is flowing here in this direction. So what this drop will be? This drop will be I in into RD. I in into RD. I in into RD. So what will be the current in upward direction? The current in upward direction would be GM2 I in into RD, right? GM2 I in into RD. Now this current would be the same here. Let's just forget I in out. So this current would be same here as well. That would be GM2 I in into RD, right? Now this current here will give you the voltage drop of GM2 R into RD into I in. Say yes or no, right? So basically this voltage is, are you getting this point? I in current was flowing here. This is I in into RD. This is GM2 I in into RD. The same current is flowing in this loop as well. So this current would be GM2 R into RD into V. Now this voltage will also be GM2 R into RD into I in. Well and good. Now what you can write in terms of I in. So what is I in? I in is V in minus GM2 R into RD I in into GM1. into GM1, that is equals to I in. Say yes or no. Did you understand this? I found out the voltage here. So GM1 VSG, GM1 VSG in upward direction, GM1 VSG, V in minus GM2 R minus R into RD into I in. Well and good, very easy. So GM1 V in would be equals to I in into, one issue is there that this will be negative, this sign will be negative, this will be positive here, right? This drop will be plus minus like this, right? So this will be positive, and here you will get 1 minus GM2 R into RD, right? So V in by I in. Just a second. Yeah, so actually I missed GM1 here, right? It would be 1 minus. I hope you are solving it on your own and not watching my solution, because this should be solved by your own only. You have solved a lot of problem and now you should be comfortable. V in by I in. I'm pretty sure 99.95% of aspirant cannot solve this particular problem as well. Forget about with the concept of feedback. Without the concept of feedback, they cannot solve it. But you have studied so much deeply now, you should be able to solve, right? 95% of the aspirant will skip this problem in the examination. I can write it down on the paper. I will put this problem in the test series and you can see. Very less people will be able to solve. It seems like that this current is like that, this current is like that, but it doesn't click to people if they haven't studied it very deeply. Because what people do, they make the model. If they are making the model, forget about this kind of analysis. Just forget about that. Okay, so V in by I in would be 1 by GM1, 1 by GM2 RD into 1 by GM, 1 by GM1. That's it. This is your V in by I. Right? Now the next you need to find output impedance. So this will be the circuit for the output impedance. Now in output impedance, I will make a correction in the given circuit, that is, this was the given question now. So in this one, I will make a correction that the arrow should not be downward. If arrow is downward, that means you are looking impedance from this way. But I need to look the impedance from the output node. So this I am calling as RY. Okay. So this arrow will say that you need to look downward as well and you need to look upward as well, not just downward. Well and good. So upward and downward, both impedance I need to take in action. So I need to find the output impedance now. So for output impedance, I have applied a Vy and I will get a Iy out of it. So what will be my output impedance? That would be Vy by Iy. That would be my output impedance. Right. So this is what I need to find. So what I will do? Let's just call downward current as Ia. There are two components of Iy. One I am calling Ia. The other one I am calling Ib. The other one I am calling Ib, or let's just forget Ib, because I am going to find Ib in terms of Ia only. So if this downward current is Ia, so what will be this potential? This potential will be Ia into R. Say yes or no. Ia current is downward, Ia into R. If this potential is Ia into R, what will be this current? This current would be GM1 Ia into R, VGS into GM1. Now this current is flowing in downward direction, so the drop will be something like this. So what will be this potential? This potential would be GM1 RD Ia into R. This is the negative potential. If this is the negative potential, then what will be the current in the downward direction? The current in the downward direction would be GM1 GM2 RD R into Ia. Say yes or no. Are you getting this point? Just Ia current, then the potential, then the current. Current there, then this potential. If this potential is there, then what is the current? GM2 VSG. GM2 VSG. So GM2 into this potential, and there will be negative sign as well because source potential is 0. So GM2 GM1 RD into R into Ia. So basically this is the scene that this is your Vy, this is your Iy. From upward direction there is a current coming, that is GM1 GM2 RD into RIA, and in the downward direction there is a current, that is IA. What is the value of IA? IA is Vy by R plus R. Say yes or no. IA is equals to Vy by R plus R, right? Vy by R plus R, because there is 0 ampere current in this direction. This is the potential, this is not the current. So there is 0 ampere current in this direction. So Vy by R plus R is IA, right? This is your IA. So basically now you can put what will be your Iy. So Iy plus GM1, GM2, RD, RIA. IA is Vy by R plus R. That would be equals to IA only, and IA is Vy by R plus R. This current plus this current is equals to this current. These two currents are coming. This current plus this current is equals to this current. So Iy would be equals to 1 minus GM1, GM2, RDR divided by R plus R into Vy. So what will be Vy by Iy? Vy by Iy, that is our Ry. That would be R plus R divided by 1 minus GM1, GM2, RDR. That's it. This is the final answer. Well and good. So this we have found. Very easy expression it is. We are finding without the concept of feedback topology. Now we have to use the brain. Here no brain is used. It is just the regression analysis. Vy by R plus R, then this voltage, then this current, then this voltage, this current. No brain is used here. Now the brain will be used. Now you have to find with the concept of feedback topology. So what you will do? So I will copy this circuit only. Actually, I took a break in between. That's why there is a cut in the video. Now I am looking fresh, right? So at that time it was 8 a.m. in the morning. I was recording for the complete night because I need to put the marathon video on YouTube. So I was recording for the whole night. So I took a break. Now I'm again recording after having a good sleep. Yeah. Okay, then that's it. So first thing, you need to make open loop. How will you make the open loop? Think about it. Make it on your own. How will you make the open loop? This is the closed loop. Now we are going to make open loop. I'm not going to draw the block diagram this time. What is happening here? Okay, I forgot to tell the feedback topology. I forgot to tell the feedback topology. How will you determine the feedback topology? What kind of feedback topology is there? Output current is being fed to the input in terms of voltage, right? So it is current voltage feedback topology. Current voltage feedback topology. Otherwise, how you can see? For mixing, what do we need to see? For mixing, what we need to see, is there two paths for the current? This is your IN current. Is there two paths for the current? No, IN current is directly flowing in this way. IN current is not being divided into two paths. So there is no current mixing. That means certainly there is voltage mixing. So one thing you can say, that there is voltage mixing. Voltage mixing. I told you the method. What was the shortcut method? That you need to take out the current and you need to see if there are two paths. If current is being mixed or not. Current is not being mixed. So directly current is going in. So there is no current mixing. What about sampling? For sampling, what did I told you? You need to look at the output voltage. If I put output voltage equals to 0, if I put output voltage equals to 0, will there be some feedback factor? Yes, there will be some feedback factor, because this is your I out. I out is the current flowing in R plus R. So still there will be I not R feedback factor will be there. So even if you put V naught equals to 0, there is still some feedback factors. That means there is current sampling. This is the other way, right? So now current sampling is there and I naught R is being fed. This I naught R is being fed. So this is the feedback path. Now I need to break it. How will I break it? What is being fed? This is your control system. At the input side there is voltage mixing. So this is V in, and voltage is being fed. This I naught R is the voltage. You don't want this voltage, you don't want this voltage, you want this voltage to be 0. So this node will be grounded, right? You don't want any voltage to come. You don't want any voltage to come. And in the feedback path, you want this voltage to sustain. You want this voltage to sustain. So this path will be open circuited. If I short it, if I short this path, there is no meaning of that, because feedback factor will be gone. I need feedback. I need the feedback to sustain. So I naught R I need in action. If I put I naught R to grounded, I naught R will be gone. There will be no use of that. So I don't want that. But at the input side, I don't want my feedback. At the input side, I don't want my feedback. I want 0 voltage at the input side. If I want 0 voltage at the input side, I need to short circuit this. So this end will be open circuited, this end will be shorted. That's it. So let's make the open loop diagram now. This end is shorted. This was RD resistance, and this voltage was fed to M2. This is also grounded. This is R plus R, and this end is open. This end is open, right? And this is your V out. Sorry, this is not grounded. This is your V in. But what we are interested in, we are interested in I out by V in. We are interested in I out by V in. So what will be your I out by V in? Tell me. This is the V in voltage. So what will be the current here? That would be GM1 V in. GM1 V in. The current is GM1 V in. So what will be the drop here? The drop will be in this direction. GM1 RD V in. So what will be the current downward? The current downward would be minus GM1 RD into V in. This is the current downward. Well and good. GM1 V in current upward. This voltage drop GM1 RD V in. And what will be the current downward? Current downward would be GM1 RD into GM2. I forgot to write GM2 into GM2 RD V in. So what is your I out by V in? I out by V in. You can call it open loop. So what is your open loop gain? That is minus GM1 GM2 RD. This is your open loop gain. This is one of the important factor. This is your open loop gain. What is the feedback factor? What is the feedback factor? What is your feedback? Feedback is the voltage. Let's find the feedback factor here. So feedback is the voltage that was I naught R. Feedback is the voltage that was I naught R. Well and good. So VF by I naught. Feedback by I naught. Like we remember this VF equals to beta V naught. So what is your feedback? VF by V naught. Similarly, VF by I naught is the feedback factor here. So the feedback factor is R. So feedback factor is R. This is the feedback factor. Very good. So this was the gain. This was the open loop gain. This is the feedback factor. Let's find open loop input resistance. Open loop input resistance. R in open loop. What is that? Simply you can see from here. That is 1 by GM. Right? That is 1 by GM1. Let's find R out open loop. What that would be? R out open loop. R out. From here you need to find R out. So if you find R out, what will happen to this what will happen to this V in? V in will be grounded. If V in is grounded, this will be gone. If this is gone, that means there is 0 ampere current. If there is 0 ampere current, that means this will be grounded. If this is grounded, that means this is completely gone. Say yes or no. V in is gone, so M1 is gone. If M1 is gone, RD is having 0 ampere current, so this node is grounded. If this node is grounded, VSG is also gone. That means M2 is also gone. So complete this much portion is gone. So what do you see from R out? R plus R only. That's it. R plus R. This is your open loop, R in open loop, and this is your R naught closed loop. Now you need to find closed loop gain. Closed loop gain. So closed loop gain directly I am going to write. So what will be the closed loop gain? Open loop gain divided by 1 plus loop gain. Open loop gain divided by 1 plus loop gain. What will be loop gain? Loop gain will be A beta. Loop gain will be A beta, right? So your open loop gain is minus GM1, GM2 RD and your feedback factor is R. So what will be your gain? Gain will be minus GM1, GM2 RD upon 1 plus A beta. 1 plus A beta. A is this negative sign into R. So here I will put negative sign only. Minus GM1, GM2 RD into R. This is the final closed loop gain. Now people will have one doubt that, sir, this is a positive feedback system. This is a positive feedback system. So why not I should put A upon 1 minus A beta. So it would be minus GM1, GM2 RD into 1 plus GM1, GM2 RD. This should have been the answer, sir. Because this is a positive feedback system. We explained in the initial part that it is a positive feedback system. So why should not I do this thing? Look, what is happening here is that, what was your V in? This was your V in. So let's make a closed loop, let's make a control system here. So what was happening in this problem? This was your V in that was coming. There would have been some gain, I don't know. There was this output current, I out. Now this I out was being fed to the feedback factor, that was R. That was R. I out R. Now tell me one thing, this I out R is being added or subtracted? This I out R being added or subtracted from the input? From the input it is subtracted. V in minus I naught R is the current into GM. That is the current, no? Are you getting this point? What is the current here? The current here is V in minus I naught R. It's not being added. It is being subtracted only. So here it is acting as negative feedback only. This is acting as negative feedback only. Then sir, why you are saying that it is a positive feedback system? When it is being subtracted only, why you are saying this is a positive feedback system? Because this gain A is negative. This gain A is negative. So let's see what will happen. If I increase this I out, what will happen? This node will increase. If this node will increase, that means it is being subtracted, so this node will decrease. But now this node will be multiplied with the negative value, so this node will be increased only. So although the value is being subtracted only, still it is working as positive feedback because the gain is negative. Say yes or no. Did you understand this point? I could have done one more thing. What I could have done? I would have made this as positive and the gain as from negative to positive only. Then it would feel like that it is a positive feedback system. But still, if I am not making this positive and I am keeping that as negative only, still it is a positive feedback system only. Because why so? Because this block is giving you a negative gain. So what is your formula? Your formula becomes A upon 1 plus A beta only. A upon 1 plus A beta only. But your A is negative. This gain A is negative. What was the open loop gain? Open loop gain was minus GM1, GM2 RD. So because the open loop gain is negative, that's why it is acting as a positive feedback system. But the formula that we have applied is only A upon 1 plus A beta, where A is negative. If A is negative, if open loop gain is negative, that's why it is becoming a negative feedback system. Not because from output something is being added. No, from output something is being subtracted only. But still it is a positive feedback system. Why is it so? Because the forward gain is negative. Are you able to understand the point or not? I hope it is all clear to you, right? So I will just keep it here as it is so that you guys are able to catch up the data. So that's why I said it requires higher level of patience and higher level of intelligence, and have the patience, try to understand all those things. Even if you are not able to recall this data, even if you are not able to recollect this data, it is not that much important for the perspective of gate examination or the interview. But if I had been the interviewer, I would ask these kind of questions to the candidate so that I could test his brain, right? So just to develop your problem solving skills, I am teaching you all these things, because who knows IIT professor frames a question where you will be able to, where you need to use these kind of things. Who knows in what question you need to use these kind of things. So that's why I am teaching you everything that can be asked. I hope you are able to understand what was the motive behind taking this particular problem, right? So this is a positive feedback system. It looks like this is a negative feedback system because something is being subtracted, but still it is a positive feedback system because the gain that we are getting is negative. Well and good. Let's find the closed loop. Let's find Rx value. Directly I am writing Rx. So what will be your Rx? R in open loop, R in open loop into 1 plus A beta. So directly I am going to write what is R in open loop. That is 1 by gm1 into this factor, 1 minus gm1 gm2 rd into r. What about ry? Ry would be r plus r into this factor. Because why so? Because my output is current and input is voltage. Output is current, input is voltage. That means it is a transconductance amplifier. For the transconductance amplifier, input is voltage. So if voltage is input, that means I need higher input resistance, so that more and more voltage coming across Rin. And for output, I need higher output only, higher output resistance only. Why so? Because output is current. So I would want less current to go in the output, but more current to go in the load. So I would want less current to go in the output resistance. So I want R0 to be as high as possible. I am repeating all these things again and again so that you remember it for a longer time. You also need to repeat it again and again so that you remember it for a longer time. That what is the input resistance, what is the output resistance. So this is how we have solved this problem as well with the concept of feedback. So with the concept of feedback, you are able to write down the answer very quickly. You are able to write down the answer very quickly. If you can see the feedback, okay, this is the feedback. What kind of feedback is that? What kind of gain I am getting? Okay, this kind of gain I am getting. This is being subtracted. So directly I am going to write closed loop gain, open loop gain, in open loop input impedance, output impedance, and these resistances as well. Well and good. Let's move on to our next feedback topology, that is current feedback topology. करंट फीडबैक टोपोलॉजी. काफी करंट लग रहा है, काफी करंट लगेगा भाई अब. Okay, this is the last feedback topology and it is very simple. So what is current feedback topology? So from output, current is being sampled and it is fed back to input in terms of current only. Current you are taking and feeding back in terms of current only. So I out is being fed and then it is being converted into current only and it is being mixed with the input current. So current sampling and current mixing. What is open loop gain? Open loop gain I am assuming it to be AI. Open loop input impedance I am assuming it to be R in and R out. So what will be your closed loop gain? Closed loop gain will simply be AI upon 1 plus AI beta I. Right? Second thing, what will be closed loop input impedance? So tell me, what do you need? Your input is current. You want your Rin to be high or low? You want your Rin to be low so that more and more current goes into Rin. So you want your Rin to be low. So that would be Rin upon 1 plus AI beta I. Now what about R0? Closed loop output impedance. So your output is current. The amplified version is the current. This is the current. And then you have a R0 and then you have a RL. So what do you want? You want more and more current to go in the load. That means you want very lesser current here. If you want very lesser current here, that means you want it to be high. If R0 is high, then only there will be lesser current here. So you want your R0 to be high. So R0 into 1 plus AI beta I. Well and good. Everything is crystal clear. No issue with that. Okay. Let's move on to our question. So first let's determine the type of feedback. How will you determine the type of feedback? You can take any node, but one thing you need to notice is that this will be open circuited. The input source will be nullified. Current source will be open circuited. So what if I increase this I out? If I increase this I out, this node voltage will increase. If this node voltage is increasing, that means certainly this node voltage will increase. Now if from here to here there is 0° phase shift, so if this is increasing, then certainly this will increase. Now what is this? This is a common source amplifier. We are going from gate to drain. So from gate to drain, this node will decrease. If this node is decreasing, then certainly this node will decrease. So what kind of feedback is there? It is a negative feedback. Again I will tell you, I increased I out, or you can increase any node. Let's just assume I am increasing this node, then what is happening? This node is increasing. If this is increasing, then this is also increasing. If this is increasing, this will give you 180° phase shift, so this will decrease. If this is decreasing, that means certainly this node will also decrease. So you increased it and it is being decreased. So this is a negative feedback system. Negative feedback is there. Well and good. What kind of feedback topology is there? For feedback topology, let's just first put the Vout value. Vout value should have been given here. Let's just assume this is your Vout, and they should give Ry like this. This is your Ry, right? So output current, this is I out, that is coming, that is being divided into two paths. So there is current is being sampled. Now current will be mixed. Let's see the mixing first. Forget about sampling. Let's see the mixing first. So this IS current has two paths, this path and this path. So certainly you can say current mixing. Right. Now even if you put V naught equals to 0, if you put V naught equals to 0, there will certainly be some I out current. Why so? Because there will be some voltage here. If there is some voltage here, that means this will drive some current. If this will drive some current, then there will be some I out. Now some I out is coming. If there is some I out, your feedback factor is not depending on V naught. Your feedback value is not depending on V naught. Whatever the value that you get, that is not depending on V naught. So that means there is current sampling, there is not voltage sampling. If it was depending on V naught only, then there would have been voltage sampling, but there is current sampling. So current mixing and current sampling. Look, I have very high gut feeling that this year in 2025 they are going to ask a very good question from feedback topology. Very high gut feeling I am having. From feedback topology there can be very good question. One question will be there, that would be very good from feedback topology, especially in EC question paper. Okay, this is what I feel. So current mixing and current sampling. So this is current feedback topology. So this output current is coming, that is being sampled in two direction and being mixed with the input current. This is also you can see. Output current is coming, that is being sampled in two direction and being mixed with the input current. This is also you can see. This is a negative feedback system and there is current feedback topology. Well and good. Let's determine all the values. First we will determine without the concept of feedback. So method 1, without the concept of feedback topology. But let's see it in the next lecture, because this lecture will be very big if I start solving it here. So let's see it in the next lecture. In next lecture we will see the concept, we will see this question with the concept of feedback topology and without the concept of feedback topology. There will be very interesting factor in this question. One interesting factor will come in this particular question. Then we will solve a few more questions based on feedback topology as well. So that will be kind of assignment only, but we will solve a few more questions. Okay, so let's meet you in the next lecture.